Hello wonderful person, this is Anton, and today we're going to discuss the recent discovery of the third interstellar comet, a mysterious object coming from somewhere else out there that after just a few days of discovery has now been officially confirmed to be definitely interstellar. It's not from the solar system for sure. And so in this video, let's discuss some of the recent discoveries in just the last few days, talk about some of the major updates, but I guess first a super quick clarification about what's happening with the background here. You might have seen the announcement on YouTube, but yeah, my studio got flooded, I lost a lot of hardware, I lost a lot of footage, and have to now wait for the new stuff to arrive. And so in the meanwhile, I decided to just take a break, go on a bit of a travel tour with my son, and basically make these somewhat impromptu videos from this incredible location in my hotel room. And so my apologies if the quality is maybe not up to par. But anyway, I still wanted to talk about this, wanted to discuss some of the stuff that was recently discovered about the comet, and of course why this is kind of super exciting as well. And so let's dive into this somewhat extraordinary astronomical event that already captured the attention of astronomers worldwide. And well, the name is 3I Atlas. 3I because it's third interstellar object. And if you've been following astronomy long enough, you probably remember the first two. In 2017, we had the famous Oumuamua, the object that caused a lot of controversy when someone proposed that maybe it's actually some kind of an alien probe. Today we know that it's very likely not. It was, however, super intriguing because it started to produce cometary features without a physical tail. But you may want to check out some of the previous videos in the description that explain why. The second object in 2019 was 2I Borisov, a very different object that almost right away produced a tail, but also had somewhat unique composition compared to comets in our own solar system. And so here we had these two different objects, actually very different objects, which means that for the past 6 years, astronomers were eagerly waiting for the third arrival. Was it going to look like Oumuamua, something that looks like Borisov, or something else entirely? And the answer is, yeah, this one, the third one, is completely different. And though we still know very little about it, its journey from the depths of the interstellar space offers us a great opportunity to learn about the universe beyond our cosmic neighborhood. But how exactly was it found? Well, it only happened a few days back from when I'm making this video, July 1st. On July 1st, 2025, NASA-funded Atlas Survey Telescope located in Rio Hurtado, Chile, discovered a bizarre dot. A dot that was moving just a little bit too fast, so it received its provisional name, A11PI3Z. And though these discoveries do happen quite a lot, there was something different about this one. Within just a few days, follow-up observations and analysis of pre-discoveries from previous telescopes, including Zwicky Transient Facility, confirmed that this was moving way too fast. As a matter of fact, this was the fastest we've ever seen anything move, other than of course our own probes. Here the velocity was confirmed to be 61 km per second or 38 miles per second at a distance of 670 million kilometers or 4.5 astronomical units. And because of this very fast velocity, it meant that it had to pass through the solar system and could not be orbiting anything. It was on what's known as a hyperbolic path, or essentially it contained hyperbolic excess velocity. And so its velocity was just a little bit too high to be captured by the sun or by any other object. And that means that it's going to pass through the solar system very quickly and will continue its journey back into the vastness of interstellar space, never to return. With this excess hyperbolic velocity also suggesting that it originated from a very faraway star ejected from its home system a long time ago. But exactly how it was ejected or by what is of course unknown. And at first it wasn't even clear if this was a comet or an asteroid either. Mostly because it was not clear if it was actually emitting anything, but that became pretty clear when the coma was officially discovered. As a matter of fact, it's now established that its coma has a somewhat reddish color, kind of similar to the comet Borisov, which indicates a lot of dust. And it seems to be emitting so much dust that all of it is covering the nucleus, preventing us from seeing how fast the comet is spinning. The shell of reflective dust is so thick right now, it's impossible to see through it. And so right now it just looks like a tiny fuzzy object, which offers us a really important hint. It seems to be mostly made out of ice and not rock. And on top of this, this is the largest of 3 objects discovered so far. According to current measurements, it could be up to about 20 kilometers or 12 miles in size. But once again, because it's so fuzzy, it could also be just a few hundred meters across. So the true size is not going to be known for quite some time. But because it's already visible and because it's emitting so much dust, it is believed to be pretty large. And luckily for us, this was discovered pretty far away from the Sun. So right now it's still approaching the Sun, and it's going to reach its closest point sometimes in October. But unfortunately for us, on October 29th, when it's supposed to be at the closest point, it's also going to be behind the Sun from the perspective of planet Earth. In other words, we're not going to be able to directly observe it with the telescopes from the planet. However, there's something else we can do. Apparently at that point, it's also going to be extremely close to Mars. As a matter of fact, it's going to pass approximately 0.2 AU away from Mars, appearing as an object with a magnitude of 11. And that means that some of the Mars orbiters might be able to observe it and may be able to report what they see. And from planet Earth is going to become visible once again, sometimes in December of 2025. Although without a telescope, it is going to be almost impossible to see. It's just not bright enough. But technically, it's already pretty close to the Sun, so it's kind of curious that we didn't see it until now. And while it might be because of where it's technically coming from, or where it was located a few months back. One of the main reasons it was not discovered earlier is possibly because it was passing the galactic center, which is an extremely dense region with a lot of stars, a lot of dust, a lot of objects, and where trying to find a tiny dot would be practically impossible. But because it was now officially discovered, in the next few months there are going to be a lot of additional observations, including potential observations with the James Webb, revealing exactly what's going on here and what this is made out of. And I guess just so that we're clear, this is definitely not an alien probe again. I'm sorry if this disappoints you. But because this is a comet, as it warms up and gets closer, the ices on the surface are going to sublimate, creating a huge coma made out of gas and dust. That's going to help us understand what it's probably made out of. And that's because it's going to become possible to see what sort of molecules are coming from the surface. And that can hold a lot of clues about the nature of a lot of interstellar objects, and of course about planetary formation and star systems out there. Because this is a pristine primordial remnant, similar to many comets in the solar system, representing leftovers of planetary formation billions of years ago. And so by analyzing all of this ice and dust, we'll eventually know exactly what this formed from, and by analyzing the trajectory, we might even find the home star system where it came from. Now for Borisov and Oumuamua, we've discussed some of the previous candidates, but right now there is really nothing concrete. Although because this comet was discovered so early, and because we have so much time to study it, we might end up with a lot more data, focusing on the chemical makeup of this object and discovering its exact composition. Because right now all we see is just a tiny blur surrounded by a tiny tail. And this will hopefully tell us if other star systems are built similar to ours, or if they contain entirely different compositions. Likewise, this might help us explain how these objects get ejected, and how comets or even planets might get kicked out from their home systems. Naturally, right now, none of this is known. Although here one thing is a little bit unusual. This object is extremely bright. And that's very likely because of the reflection from the dust, implying that there is a lot of pristine material that's never seen any other star before. And so because it's so bright, and because it's much bigger than previous two objects, scientists will be able to get much more data from this than was previously possible. But because it's so much faster, there's absolutely no way we'll ever be able to catch it, or perform any kind of a retrieval mission. And so here we can only observe this comet from a distance. Although intriguingly, missions like the European Space Agency's Comet Interceptor that's supposed to launch in 2029 is actually designed precisely for this type of a mission. It's designed to rendezvous with some of these comets, assuming they're not moving too fast. But we'll talk more about this closer to the mission in 2029. But a much more exciting type of discoveries are going to come from the Vera Rubin Observatory in Chile. We've recently discussed this during the live stream with a link in the description, but here, based on statistical analysis, we actually expect to find pretty much one every month. And that's based on the assumption that 10,000 such objects exist in the solar system, we just cannot see them very well. And so once we find hundreds or even thousands of these, we'll be able to tackle a lot more questions. For example, maybe some of them will contain precursors of life, such as amino acids, providing more clues about potential life in other star systems. Or maybe one of these comets will help us explore the fascinating concept of panspermia, the hypothesis that life, or at least a lot of the building blocks, can be transferred between celestial bodies, between various star systems, and between comets and asteroids. And so for all we know, we'll discover something super exciting once more telescopes become operational and once more of these objects are discovered. And so here, because the solar system is basically like this giant net catching all of these objects all the time, the biggest challenge today has always been detecting them. But with Vera Rubin and James Webb, we'll be able to catch them, analyze them, and learn so much about them in mere months. And so the discovery of 3I Atlas serves as a powerful reminder of how much we've come as a species, and of course about the dynamic interconnected nature of the entire galaxy. Each of these interstellar visitors is a unique messenger, each of them carries its own secrets, and each of them is going to help us uncover so much more about the entire galaxy and the possibility of extraterrestrial life. But until future discoveries, that's, at least for now, all we know. Hello wonderful person, this is Anton, and today we're going to do a bit of an update about that third interstellar comet that's visiting the solar system and was discovered on July 1st of 2025. The comet, now referred to as 3I Atlas. 3I in this case refers to the fact that this is the third interstellar comet. And it just so happens that just a few hours ago, we finally got new images. Which means that we definitely have to talk about this extraordinary event once again, because these bizarre cosmic visitors, at least as of today, are definitely super unique. And while it's now officially confirmed that not only is this an object from outside of the solar system, it also is potentially the oldest comet ever observed, which, if correct, provides us with unprecedented window into the formation of star systems far, far away, and might even help us explain the history of the galaxy itself. And so let's briefly discuss some of the new updates, talk about this comet once again, but let's also start with the brief introduction to how this was discovered. And here, as always, this was completely by accident. On July 1st of 2025, images captured by the NASA-funded Asteroid Terrestrial Impact Last Alert System, also known as ATLAS, that routinely scans the night skies for various moving objects, discovered something somewhat bizarre. An object moving at 130,000 miles per hour, or approximately 210,000 kilometers per hour, or close to about 60 kilometers per second. And it was really this extreme velocity, combined with its unusual trajectory, that indicated that this is a unique object. Because first of all, unlike other comets, here the trajectory was not parabolic, it was hyperbolic, where the eccentricity in this case was more than 1. And this is exactly what's expected from interstellar comets. For example, for the first comet, Oumuamua, the eccentricity was 1.2. For the second comet, Borisov, it was 3.6, but this one had it at 6.2. This was a highly hyperbolic orbit, and there was absolutely no way this was coming from the solar system at all. And it actually only took a few days to confirm all of this, just because of the extreme velocity and because of the extreme orbit. As a matter of fact, it only took 24 hours to confirm its interstellar nature. And it actually only took a few days for a team of 40 astronomers from the Michigan State University to quickly release the first scientific paper describing this object and explaining what we know about it so far. And that of course shows you how exciting this event already was. And so here the scientific urgency was kind of warranted, mostly because we only had one shot at observing this object, and because within the next year it's most likely going to be extremely difficult to see. But I guess now let's talk about one of the recent discoveries in regards to its potentially unusual origins, or where it possibly came from. This is based on some of the recent studies you can find in the description, but here we now have at least one study analyzing its trajectory and trying to figure out its origins and possibly its age. And the initial results are somewhat surprising. Now first, let's briefly discuss the trajectory of two previous comets, just so that all this makes sense. Oumuamua and comet Borisov both entered the solar system largely head-on, relative to the trajectory of the Sun across the Milky Way, which implied that their origin seems to be from the galaxy's main thin disk, where the majority of stars reside. And here it's actually important to understand that our galaxy seems to contain two separate disks with two separate origin stories. And it sort of looks like this. As you can see, the Sun is also inside the thin disk. But there's also a thick disk, which is quite often found in a lot of these galaxies and seems to be present in at least 60% of all of them, suggesting that most of them form in a very similar way. And pretty much all of the stars inside the thick disk are very different in terms of chemistry and motion compared to what we have inside the thin disk. For example, most of the stars in this case seem to be much lower in metals, suggesting they're much older. And well, it just so happens that this particular comet seems to be coming toward the solar system side on, indicating a very different origin, with the recent simulations presented at the Royal Astronomical Society National Astronomy meeting in Durham, England, implying that this comet most likely originated from this thick disk containing much older stars, which in short represents a lot of ancient stars above and below the thin disk, and that seems to contain at least 10 to maybe 15% of all Milky Way stars, which existed here for billions of years. As a matter of fact, most of the stars in this part of the galaxy are believed to be billions of years older than the solar system, mostly due to their low metallicity. And this implies that this comet could be the first interstellar object to have come from an extremely ancient star. In this case, this conclusion was reached by using a novel computer program known as Autotachi-Oxford model. You can learn about this in the study in the description. And intriguingly, the main author of this paper actually just finished defending his thesis, specifically on this topic, right before the comet was discovered. And so for Matthew Hopkins, a doctoral candidate at the University of Oxford, this was a perfect real-life opportunity to prove his point. And to prove this, researchers used data from the ESA's Gaia Space Telescope and combined this with models of protoplanetary disk chemistry and galactic dynamics, with the results suggesting that both velocity and the trajectory of this comet seem to fall within the expected range for such an origin. And because this comet most likely formed from various leftovers around these ancient thick disk stars, here the scientists suggest that 3I Atlas could be at least 3 billion years older than the solar system, but possibly even older than that. So essentially at least 7.5 to maybe 9 billion years old. But what's even more bizarre is that for pretty much most of this time, this comet possibly drifted through interstellar space without interacting with anything. Although obviously exactly how old the comet is currently unknown. And so this definitely makes this the oldest comet we've ever seen anywhere. And assuming that this is correct, and assuming that this indeed came from these ancient stars in the thick disk, here the implication is that this is going to be a comet much lower in metals and much higher in ices, resulting in a much higher water content, and thus resulting in an enormous tail. And so here we're going to have our first test really soon. As this comet approaches the Sun, the expectation is that we're going to see huge amounts of water spewing from the comet, making all of this very easily visible. And because the closest approach to the Sun is going to happen around October 2025, sometimes between September and November, we're probably going to be able to tell for sure if this is indeed one of these ancient thick disk comets. But right now, this is essentially the best image we have. This is from the Gemini North multi-object spectrograph that shows us an extremely compact coma, or the cloud of gas and dust surrounding the icy nucleus, with this image also kind of confirming that this comet is indeed pretty large. Compared to Oumuamua that was about 200 meters across, and compared to Borisov that was just under 1 kilometer, this here seems to be at least 20 kilometers. So this is a relatively large object. And because it's so large, it's also going to make it much easier to study, making the next few months super exciting for a lot of astronomers. But at the moment, some of the first observations don't actually show us too much. Right now the comet itself seems to be just a little bit bluer with a slightly redder coma, compared to at least what we expect from the solar system, but by itself this is not too unusual. And so some of the recent observations have not really discovered anything strange yet. But that's also because the comet is still pretty far away. Right now it's somewhere near the Jupiter's orbit at a distance of over 460 million kilometers or 290 million miles. But it's also approaching the Sun super quickly at nearly 60 kilometers per second. And it's also going to be at its closest approach to planet Earth sometimes around December 19th. although luckily for us, it's still going to be pretty far away, nearly twice the distance of Earth to the Sun, which means that it poses absolutely no threat. And at the moment, astronomers think that it's most likely not going to be visible to the naked eye, but will probably be visible to most telescopes and most stargazing binoculars, especially sometimes in the late 2025, early 2026. But at the same time, between September and December of 2025, we're unlikely to get any more updates, and for one reason. It's actually going to be behind the sun. You can actually see all of this in the simulation right here, created by researchers from the Arizona University. But at the moment, everyone is waiting for the pictures from two specific telescopes, the Hubble Space Telescope and the James Webb. And that's because they're able to study these objects in multiple wavelengths and can definitively reveal the chemical composition, the size, and even the structure of these objects. Although here, because the comet is moving pretty fast, it's not entirely certain if they're going to be able to capture it directly. But it's also possible that some of the NASA's rovers and some of the NASA's orbiters might be also able to see this comet as well, because it's going to be passing really close to Mars at the end of the year. And so hopefully by early 2026, we're going to have a lot of observations and quite a lot of studies talking about what astronomers discovered on this object, and possibly discussing its origins in more details, because in this case, this is literally a direct sample from a part of the galaxy we've never seen up close anywhere before. And so this can help us study the chemistry and the dynamics across the galaxy, but also provide some answers about how ancient interstellar comets might have played a role in seeding stars and planets early on. Because today we believe that at least 10,000 such objects are currently somewhere in the solar system, and that means that they possibly do interact with planets at least to some extent, and maybe even collide with certain planets, delivering something to their surface. And well, luckily for us, the telescope that's going to be able to find a lot of these objects just became operational. That's of course the Vera Rubin Observatory we recently discussed during one of the streams. This observatory is going to be able to detect these comets all over the place, and chances are we're going to be finding them pretty much every month. And so by itself, this is a super exciting event. An event that will hopefully teach us so much more about our own galaxy, addressing humanity's deep curiosity about the universe, and possibly even answering questions about life somewhere out there, and whether there is anyone else out there. And so this ancient messenger from the thick disk of the galaxy creates a perfect opportunity to sample the building blocks of star systems billions of years older than our own. And though at the moment visiting this object is sort of out of the question, there's still a way for us to study everything about it by observing this with some of the modern telescopes like the James Webb. Hello wonderful person, this is Anton, and once again we're going to have to discuss the third interstellar comet discovered in the solar system, the comet 3I Atlas. The comet that was accidentally discovered just a few weeks ago, and the object that captured the attention of astronomers worldwide. But it didn't take long to already cause a bit of controversy, particularly around new claims that maybe this is not just some kind of a natural space rock. And yeah, you might have guessed who this is coming from. The now somewhat controversial Israeli scientist, Avi Loeb. The Harvard scientist that became super popular after his original proposition in 2017 that the first interstellar comet Oumuamua was potentially an extraterrestrial probe. And so in this video, I wanted to break down some of the facts we know about this object, talk about the evidence that we are pretty certain that this is a comet, and specifically address some of the Avi Loeb's claims. Mostly dissecting why, based on the scientific data, none of the claims he makes seem to hold up. And so here we're going to focus on facts and not the hype. And so first, let's establish exactly what this is. Discovered on July 1st, 2025 by NASA-funded Asteroid Terrestrial Impact Last Alert System, or ATLAS, at first this was a relatively faint and a relatively small object. But it was unusual because it was moving at blistering speed of 61 km per second. Something that was completely unexpected for any natural object. And follow-up observations within the next few days confirmed its hyperbolic trajectory, which was a key indicator that this was an interstellar object coming from outside of the solar system. It was moving way too fast to be gravitationally bound to our sun, and it was definitely going to leave the solar system, never to come back. Which of course made this the third confirmed interstellar object after Oumuamua and Comet Borisov. You can learn more about both objects in some of the previous videos in the description. But the initial observations from July 1st, July 2nd contain a little bit of ambiguity about what exactly this might be, an asteroid or a comet. But within just a single day, within approximately 24 hours, multiple telescopes confirmed that this is definitely a comet. It contained a coma and a short tail. One of the first confirmations was by the Nordic Optical Telescope and was conducted by David Jewett and Jane Liu. And they definitively confirmed that this was an active object with a diffuse tail. And it was around this time that this became designated as Comet 2025 N1. So even before we confirmed that this was an interstellar object, it was already confirmed to be a comet. And this is where Avi Loeb enters the picture. Pretty much right away, he turns his attention on 3I Atlas, and on July 16, 2025, publishes a paper, side note, not a peer-reviewed paper, just a preprint, speculating that, okay, this is also possibly some kind of an extraterrestrial spacecraft, based on some of the anomalous characteristics. And so the question is, what exactly are these anomalies? Well, the first one is apparently its large size. The second one is the lack of identifiable chemicals. Also, the trajectory, in his view, was improbably aligned with the solar system, specifically the ecliptic plane, and seemed to involve close approaches to multiple planets, with the last one being the fuzziness of the object. Here, the observed fuzz was not a coma, but was just smearing due to the fast motion of the object, and not because this was a comet. And as you can imagine, pretty much right away, everyone in the scientific community drew strong criticism against this somewhat bizarre paper. And so, let's go through some of these points one by one and see what the actual evidence says. Let's start with the size. Avi Loeb and others initially used the brightness of this object to estimate the potentially large size of 3I Atlas. But, as a lot of sources clearly explain, estimating the size of a comet's nucleus is very difficult. And mostly because it's surrounded by a very bright cloud of gas that for comets we call a coma. And specifically this first point he makes seems to be completely invalidated with new observations from several additional sources. For example, here are the images from Hubble, almost definitively showing us that this is a comet. Likewise, the observations from Vera Rubin Observatory that accidentally captured the comet even before it was officially discovered actually even show us what this object was before it became too cometary, or before its tail became too large. And here the observations suggest a nucleus that's about 11.2 kilometers in diameter, or about 7 miles. And though obviously 7 miles is maybe a little bit large, and is definitely the largest interstellar comet we've seen, this is not the largest comet out there. As a matter of fact, you can learn about the largest comet we've ever seen in a somewhat recent video in the description. Now that one is definitely large, and by the way, it's also kind of headed toward us. But yeah, that one we know for sure is not aliens. And so being large does not mean that this is an alien spaceship. It just means that it's a large comet. I mean, honestly, I don't even know why I'm saying this. But the obvious giveaway was comparing the observations from Vera Rubin Observatory to some of the most recent observations that definitively show us that this object increased in brightness and now contains a tail. There is absolutely nothing artificial going on here. Okay, let's discuss the second point. Lack of identifiable chemicals. And this point was discredited almost right away. Observations from several telescopes, including Gemini South and NASA Infrared Telescope Facility, definitively showed us that the coma of this object is made out of at least water ice and potentially silicate grains, something that we almost always find inside comets. And the initial non-detection of some gases, like for example cyanides or hydroxides, seems to be consistent with comets at very large distances away from the Sun. And that's because usually comets become more active as they get closer to the Sun. Okay, I'm gonna try not to be too cynical here. Basically, he made another assumption that seems to be incorrect. But here, even the pre-discovery by NASA's TESS telescope suggests that this object was already active as far as 6.4 astronomical units away from the Sun, hinting on a lot of volatile ices, and once again suggesting that this was indeed a comet. Nothing anomalous here. But obviously all of this will be confirmed with the observations from the James Webb that's going to be able to see pretty much all of the elements inside the coma. As of recording of this video, this has not been done yet. And so the chemical evidence points directly to a natural comet once again. Third, let's tackle that smearing argument. This is perhaps the most glaring factual error in his claims. and unfortunately seems to demonstrate some kind of a fundamental misunderstanding of basic observational astronomy. And honestly, I'm kind of feeling bad even saying this. Here, Avi Loeb argues that fuzz or elongated appearance around Atlas is simply an artifact of telescope's motion relative to the object, causing the object to smear. However, multiple sources, and pretty much all of the astronomers, point out that we usually use a technique called non-sidereal tracking, which means that the telescope is programmed to follow the moving object itself rather than background stars. And the evidence for this is pretty clear in a lot of the published images, where the stars in the background are trailed while the comet itself is distinct and appears as a non-smeared, fuzzy object. It also clearly shows an extended coma, like in this image from Hubble, directly refuting Loeb's claims that this is just smearing. So there's literally no anomaly here whatsoever, and instead seems to represent some kind of a complete conceptual misunderstanding of how telescopes usually observe things. As planetary scientist Michelle Bannister noted, it has a coma. No large telescope has seen anything but a coma. Okay, we have another point to go through, the trajectory, and specifically the ecliptic alignment. Here, Avi Loeb suggests that the close approach to Venus, Mars, and Jupiter, combined with the alignment to the ecliptic plane, seems to be anomalous and could indicate a guided artificial trajectory. And while it's true that Atlas is going to pass relatively close to these planets, for example 0.2 astronomical units away from Mars and 0.4 AU from Jupiter, its trajectory is actually tilted 175 degrees with respect to the ecliptic. And so the more correct description here would be retrograde and inclined by 5 degrees. And so even though its path does bring it to the inner solar system, there's absolutely nothing anomalous about this trajectory, and nothing to suggest that anything here is artificial. As a matter of fact, as I've stated in some of the previous videos, it poses absolutely no threat to planet Earth, and at most will pass approximately 1.8 AU away from our planet. And I mean, if this was some kind of an artificial intelligence, would it not consider coming closer to our planet instead? And so no, it definitely does not have an anomalous trajectory, and it definitely is not going to pass close to inner planets. At least not to our planet. But beyond disproving these anomalies, there are obviously a lot of other evidence suggesting that this is a purely natural object, there is nothing unusual about it, except for maybe of course where it's coming from. And so the only real anomaly about this object is the fact that it seems to be coming from the really ancient part of the Milky Way, with the suggested age for this comet potentially now being over 9 billion years old. And that's because it seems to be coming from the thick disk of the Milky Way galaxy. And that's because its high vertical velocity compared to the solar system can only be explained if it came from the thick disk population hundreds of light years above the thin disk where the solar system orbits. Now we have no idea exactly where it came from, but right now the initial evidence points at this being a super ancient object. And this of course provides a plausible explanation for this just being a natural object ejected from some kind of a star system a long time ago, very likely during the planetary formation in that ancient star system 9 to 13 billion years ago. And because of the water-ice rich composition observed in its coma, we can also deduce that this object was very likely formed pretty far from the star, possibly beyond the snow line, where water ice can condense into solid form. And just like so many other comets in the solar system, it was eventually ejected, possibly through some kind of a close encounter with a giant planet, or maybe a passage of another star, something that has been simulated by various models, and something that's pretty well understood. So once again, pretty much nothing anomalous here at all. Which brings us to that main question. So why does Avi Loeb continuously push these narratives, even in face of obvious contradictory evidence? Why, Avi? Why? Well, as many of his colleagues pointed out, since 2017, Avi Loeb essentially gained all of his reputation by making these extraordinary claims, or essentially making a lot of sensationalism, very often leveraging his Harvard affiliation, simply to attract media attention and to then, sell his books. Which is exactly what he did in 2017, what he then did a few years ago with his expedition in the Pacific Ocean, and what I think he's going to be doing now again. And so, as this video by Professor Dave explores in more detail, the video that you can find in the description, he seems to have completely shifted his approach to science. A lot of his early papers, specifically from the 1980s through early 2000s, focused heavily on traditional foundational astrophysics, with emphasis on birth of first stars, black holes, large structures in the universe, and gravitational microlensing. As a matter of fact, a lot of his first papers were quite interesting, which is how he eventually got his position at Harvard, and as a leading theoretical cosmologist. But then something happened in mid-2010s. He suddenly switched to speculative and unconventional science, with his focus becoming interstellar objects like Oumuamua, and search for extraterrestrial intelligence, but usually through somewhat unusual and controversial means. And so since then, a lot of his studies have drawn a lot of criticism, mostly from scientific community, but also brought a lot of attention, primarily from media. But only because they were so speculative, and because here the priority was public engagement, or essentially going viral. And most of these recent papers have been criticized by peers, and even the larger scientific community, simply for one reason. They completely lack any scientific rigor, and are not based on any scientific approach. And in most cases, they literally read like blog posts. Which is actually why most of them never even get published in actual papers. They just end up being preprints. And so here Avi Loeb went through some kind of a shift, from primarily being an astrophysicist and a Harvard chair of astronomy to a more controversial figure focusing on SETI, UFO research, and a lot of super bizarre claims, including claims in fields he has nothing to do with, like for example psychology. And he even talks about this paper in his own blog post. And though I guess maybe some people might agree with his approach, and his approach is somewhat successful at getting him all sorts of deals, all sorts of book sales, and getting him on some big podcasts, there are of course a lot of issues with this, mostly because he's essentially saying that science is against him. But for someone who's not a scientist, or for someone who does not understand how this works, what's the big deal with Avi Loeb? Why is he criticized so much? Well, there are several reasons. Apart from the fact that he's using his position to attract media attention and to promote his books, pretty much all of his recent papers never go any kind of a rigorous peer review, and do not even get published because they cannot possibly pass scientific scrutiny. And though normally for a typical scientist you would usually try to correct your paper and possibly change your methodology just to make it, I guess, more scientific, for Avi Loeb his approach is playing victim. With every single paper he posts a blog post making himself appear as a victim of scientific attack. And as someone who's read hundreds of his papers, I would actually have to agree with the wider scientific community. A lot of his previous papers were really good. Most of his stuff in the last 10 years is basically just pulp fiction. On top of this, he often bypasses experts in the field and seems to always go to the most unusual conclusion, very often involving aliens. And when faced with any kind of a scientific criticism about this, he loves referring to himself as a Galileo figure, basically being persecuted by a close-minded scientific establishment. Which seems to work because it does gain sympathy, and further leads to promotion of his own work. But what's I guess even more interesting is that he himself, in a lot of his studies, does not necessarily take his own propositions seriously. As in, he basically says that a lot of these speculations could be an interesting exercise, but he does not specifically state that this is super 100% aliens. And it's really this part that his critics dislike the most, because this approach undermines scientific integrity. A lot of his extraordinary claims that would require extraordinary evidence end up being completely disproven, which then lead to Avi Loeb once again claiming that he's just being persecuted. And especially when it comes to these interstellar objects, this is still a field in its infancy. We only have 3 objects. And so calling any of these objects anomalous is completely unfounded. We have no idea what these objects are supposed to be. And so assuming that any of these objects are extraterrestrial probes or alien spacecraft is honestly just pure nonsense. This is definitely an incredible object, and is definitely exciting for a lot of reasons, especially because it allows us to study pristine material from another star system, but here all of the scientific evidence points at this being a natural cometary object, very rich in water, somewhat enriched in silicates, but not little green men. Although here I have to end on a small side note. What Avi Loeb does right now is also unfortunately kind of detrimental to the larger field of SETI, Search for Extraterrestrial Intelligence, which is a legitimate and important scientific endeavor that entirely relies on extremely rigorous, objective, and scientific investigation of every single detection, which usually involves evaluating all of the data, involves consulting all of the experts and communicating all of the possible concerns, and most importantly, being able to discard a hypothesis that just does not make sense anymore, especially when evidence no longer supports it. And that's where Avi Loeb fails completely. Instead of doing that, he ends up publishing a book and making money, which is why he lost most of the respect from the wider scientific community, or at least in the field of astronomy and astrophysics. And honestly, here, I don't blame them at all because, obviously everybody wants to make money somehow, but when a person becomes a grifter, that's taking things a little bit too far. And so I think this is maybe going to be my last video on Avi Loeb and his bizarre endeavors, because I don't think he's going to be publishing anything scientifically interesting anytime soon. I'm sorry if you like him or if you enjoy his books or if you actually like hearing him on podcasts, but for me personally, focusing on actual science, yeah, that's pretty much it. But we will be focusing on this particular comet in some of the future videos, especially once we have observations from the James Webb. Imagine an object hurtling through vast expanses of space for billions of years, crossing unimaginable distances, and finally making a visit to our cosmic neighborhood. But not from our solar system, from an entirely different region of the galaxy that formed much earlier than the Sun itself. And that's the remarkable story of this newly discovered 3I Atlas, the third ever discovered interstellar comet that since its discovery surprised quite a lot of astronomers, mostly because of its unique characteristics and its somewhat bizarre orbit. And so, hello wonderful person, this is Anton. In this video we're going to be discussing some of the recent updates about this new exciting comet, focusing on some of the most recent scientific observations and some of the more recent, somewhat unusual discoveries. Discoveries made by several scientific teams and by using several different telescopes in just the last 6 weeks. And that's because this is, of course, a somewhat recent discovery. This object was only seen on July 1st, 2025 by NASA-funded Asteroid Terrestrial Impact Last Stellar System, or ATLAS for short. But as we've discussed before in some of the videos in the description, it essentially became confirmed as an interstellar object within approximately 24 hours. And that's of course because of its somewhat fast velocity. Compared to the previously discovered Oumuamua and comet Borisov, this object was moving much faster. It seemed to contain an unbound hyperbolic path with the excess velocity of 58 km per second, which was much higher than 26 km and 32 km per second for Oumuamua and Borisov. But even the trajectory here was way more extreme. This was a very hyperbolic orbit with the eccentricity of 6.13, essentially making the path almost appear straight instead of being curved. And as this object approaches the Sun, its velocity is going to increase even more, reaching the maximum speed of 68 km per second at perihelion. Although unfortunately at this time we're not going to be able to see it because it's going to be behind the Sun. And once it starts leaving the solar system, its velocity is gradually going to slow down, but it's still going to remain one of the fastest objects in the solar system. And while here, as we've discussed previously, one of the more bizarre discoveries was of course in regards to the trajectory, and specifically where it came from, and its vertical velocity. Now right now what we know about it is that it seems to have come from the southern celestial hemisphere, the direction opposite to the direction of the Sun's movement relative to local stars. But more importantly, it was moving upward through the galactic plane with a vertical velocity of 18.5 km per second relative to the Sun. And this high vertical velocity is very unusual compared to nearby stars and of course other interstellar objects, in essence suggesting that 3I Atlas seems to follow a tilted orbit around the Milky Way, possibly resembling something like this. And more importantly, this places it inside the thick disk population, the region in the Milky Way galaxy that consists of predominantly very old stars that are much older than the Sun. And so in a study we mentioned previously, Matthew Hopkins and the collaborators from the United Kingdom estimated that this object seems to be at least 7.6 to maybe even 14 billion years old, with approximately 70% confidence. So this is probably the oldest comet we've ever seen, and much older than the solar system, which formed 4.6 billion years ago. But I guess what's even more surprising is that for this whole time this comet was very likely just drifting through space, not interacting with anything, with the Sun basically being the first star it's seen in a very long time. And though right now it's impossible to trace it back to the specific parent star, mostly because this happened billions and billions of years ago, and its speed and trajectory very likely changed because of various gravitational encounters. Right now this presents us with the best chance to potentially study ancient star systems by indirectly observing a piece of that star system right here in our neighborhood. Furthermore, based on the observations of the emissions and the observations of the cometary tail, specifically water-rich composition that was observed almost right away, here researchers concluded that this object formed beyond the snow line of the star system, where we usually expect water to condense into solid ice right away. And that's kind of how we expect most comets to form in most star systems. But eventually this object was gravitationally ejected from the home system, possibly through some kind of a close encounter with a giant planet similar to Jupiter. But it's really that cometary activity that's the most exciting feature, and the feature that's going to be analyzed the most in order to discover what this object is made out of. And we already have a few surprises in regards to its chemical composition. First of all, this was confirmed to be a comet almost right away because it just appeared to be very fuzzy. Much fuzzier than typical background stars. And that's of course a direct indication that this is a cometary object, with an object containing what's known as a coma, a cloud of gas and icy dust ejected from the surface because of the heating from the sun. And so here observations by NASA's TESS revealed that 3I Atlas was already exhibiting cometary activity as early as May 7, 2025. Approximately 2 months before its official discovery. And at this time it was much farther away than Jupiter. And this early activity is particularly noteworthy because temperatures at such distances are usually too cold for water ice to sublimate. Which of course suggests that the initial activity was likely driven by the sublimation of much more volatile ices, something other than water. And here the coma itself is also quite substantial. It appears slightly elliptical, and appears to be constantly expanding, and expanding quite quickly. And here observations from Vera Rubin Observatory show that the diameter grew from 13,000 kilometers on June 21st to nearly 19,000 kilometers on July 2nd, with Gran Telescopio Canarias eventually measuring it to be 26,000 kilometers in diameter, or twice as big as Earth just a few weeks after. Essentially suggesting that this cometary object grew extremely fast and expelled a lot of material very quickly. But one of the most significant discoveries here is of course water. And here water ice was detected between July 5th and 14th of 2025. And several separate telescopes were able to confirm the existence of water, observing both water vapor and hydroxide ions. And this was already visible approximately 3.5 astronomical units away from the Sun, which is technically a little bit unusual for comets, because normally we don't expect detectable amounts of water vapor and even hydroxides at such large distances because of very cold temperatures. And though right now there is no exact explanation, there is at least one potential proposition. Here scientists believe that this water vapor and hydroxides detected by these telescopes seem to be produced by sublimation of water ice grains, which must have been ejected from the nucleus by outgassing of something much more volatile, maybe carbon dioxide, maybe carbon monoxide. Or basically the comet started to evaporate much earlier because of something else on the surface, and those water particles got ejected as a result. And here the active surface area for this entire comet seems to be very large. Approximately 20% of the surface area seems to be evaporating, which is much higher, or approximately 4 times higher, than what we usually see in a typical comet in the solar system. Normally it's about 3 to 5% of the entire surface, here it's over 20%. With this increased activity, explained by the hypothesis that this comet has never seen another star for at least several billion years, suggesting that it basically just has a huge reservoir of very pristine materials that are finally evaporating because Sun is the first star they've ever seen. But in terms of other volatile elements, initial spectroscopic observations from early July of 2025 seem to have discovered no evidence of gas emissions containing cyanides, dicarbons, tricarbons, or oxygen. And here for astronomers this was maybe just a little bit surprising, because the absence of cyanogen radicals, also known as CNs, which usually have a very low sublimation point, and are typically the first signals detected in comets, seems to be just a little bit unusual. And so even though these substances are expected to exist on this comet, so far they have not been detected anywhere. And here we have at least 2 potential explanations. First one suggests some kind of a thick layer of irradiated organic compounds that seems to suppress volatile outgassing from the surface of this comet. The other one is the low metallicity origins of this comet, or essentially the fact that it came from some really ancient stars containing very low amount of heavier elements, suggesting that this unusual comet is just carbon poor and extremely enriched in water compared to anything in the solar system. And right now that second explanation seems to make the most sense. Basically this comet is just super ancient and so just seems to contain a lot more primitive stuff. Likewise here, the coma appears to be just a little bit reddish in visible wavelengths. And that's actually similar to what's known as D-type asteroids in the solar system. But also similar to active solar system comets and even previously discovered comet Borisov, all of which contained reddish complex organic compounds that must have been created through the exposure to cosmic radiation. This is, by the way, the same color and the same reason Pluto is red as well. But one of the bigger surprises in the last few weeks was this: the sun-facing dust plume, or basically a tail that's pointing toward the sun and toward the direction of motion. And so this is different from a typical tail pointing away from the sun. And though this is quite rare for comets, it is not impossible. Here, this plume is believed to be emitted from the heated, sunlit surface of the nucleus, where the ice sublimation occurs much faster. And this has been observed in other distant comets as well, which tend to preferentially eject dust from their sunlit sides. But additionally, the Hubble Space Telescope was able to discover another tail. A faint tail pointing eastwards, away from the sun, which is a much more common cometary feature, usually formed by the solar radiation pressure, blowing away small dust particles away from the comet. And so in other words, this comet seems to have quite a few tails. But based on some of the more recent observations, one thing the scientists cannot figure out yet is, of course, its true size. And that's because initially, in July of 2025, this was proposed to be a comet anywhere from 10 to 20 kilometers across, much larger than previously observed interstellar objects, and technically one of the largest comets observed in general. But the recent high-resolution images from the Hubble Space Telescope provided a much more refined estimate. Here, the new observations show us that this comet, and specifically its solid icy nucleus, is anywhere between 0.32 to maybe 5.6 kilometers across. So definitely much smaller. But the reason the size estimates are still so uncertain is really because it seems to be emitting so much stuff that it's just difficult to see the surface. Here, the reflective coma makes this object appear much brighter and larger than it actually is. As a matter of fact, it might be very similar in size to comet Borisov, but just losing way more dust at a much faster rate. But obviously, at least for now, this is just the beginning of these observations. As a matter of fact, one of the things scientists want to see is if this comet is going to have similar unusual signs of non-gravitational acceleration to what Oumuamua was showing us back in 2017. But this is most likely going to be only observed in early 2026. And mostly because, as I mentioned, this comet is just going to be hiding behind the sun, invisible from planet Earth. Nevertheless, the James Webb Space Telescope is actually going to be observing this comet again in the next few days, and is going to conduct an additional observation in December of 2025 once the comet becomes visible again. And mostly because this is not just another comet somewhere in the solar system, this is a truly unique opportunity to study processes of planetary formation in distant star systems and in a very different galactic environment from where the Sun was formed billions of years ago. And even though right now this comet appears to be similar to certain types of asteroids, specifically D-type asteroids, which are usually very dark and appear somewhat red, only additional observations in the next few months will definitively tell us more about this object and how it compares to comets we usually see in the solar system. And so here, because of its unusual age, its unusual origin, and its somewhat distinct cometary activity, it's quite likely that this is going to be the most studied object in 2025. But because this object is also leaving the solar system, there's now a kind of an ongoing race in trying to learn as much about it as possible, which actually highlights the importance of rapid scientific response in the modern age of astronomy. And as I mentioned before, as Vera Rubin Observatory becomes fully operational, it's very likely going to be discovering even more of these objects, mostly because it has much higher sensitivity and is just so much better at seeing these objects at all times. Hello wonderful person, this is Anton, and today we're going to discuss some new updates in regards to the third interstellar comet detected in the solar system, the comet referred to as 3I Atlas. And we're actually going to talk about something somewhat important, mostly because, once again, this comet has received a lot of buzz online. That's also, unfortunately, is getting a little bit too speculative and a little bit too bizarre. And so because of these new headlines, and also because of the recent email I received, I wanted to discuss the subject once again, focusing primarily on scientific facts and everything we know about the subject. And so before we start the video, I wanted to briefly address a very important concern that has now been voiced by a lot of scientists out there. As a matter of fact, this is based on several emails I've received in the last few weeks. And here we're talking about emails from actual scientists that are unfortunately somewhat upset. And so here researchers behind this recent study, especially Rohan Rahat-Gaonkar and the international team you see on this list, express deep concern that their work is being misinterpreted and actually miscommunicated by invoking very unusual exotic explanations involving aliens, and specifically alien probes. And I guess here you're probably aware who's doing all of this and why this is creating so much controversy. The Israeli researcher working at Harvard, who has unfortunately been completely misinterpreting all of these results just to once again fit his own agenda, and so that he basically can sell more books. And as I promised in some of the previous videos, we're just not going to discuss his work anymore, just because it's become completely ridiculous. And really because of what's being mentioned by these scientists and what most of the scientific community is now definitively stating. None of them support or agree with any of these interpretations, especially interpretations that attribute all of these observations to some kind of an alien spacecraft or advanced technology. Because in this study and several other studies, the evidence suggests unusual chemical signatures that can be easily explained through natural astrophysical phenomena, and actually present us with some really exciting explanations about different star systems, which is really the primary purpose for most of these studies. It's not for Avi Loeb to sell books or to try to find aliens, it's to actually figure out where this comet is from and what other star systems are like. And so understanding the chemical makeup of this object is already profoundly exciting and does not need to be embellished with some kind of an unsubstantiated claim. Because honestly here, just the science itself is already super exciting. I mean, for astrophysicists. And that's because this object is only the third such object we've ever confirmed, and it's already providing us with a very important discovery into both chemistry and physics of distant stellar systems. And so let's discuss exactly what these new discoveries are, and of course start with a very brief summary of what we know already. So, first discovered on July 1st, 2025, this object stood out because it was moving ridiculously fast, over 58 kilometers per second. And so with a very hyperbolic orbit with eccentricity of 6.14, this was the first such object ever seen. This trajectory screamed interstellar visitor. And in the last few weeks, it's actually really because of these very powerful new telescopes that it's become possible to not just track this object, but to accurately analyze its structure, its size, and even its composition, and even discover it in some of the archival data, including telescopes like TESS that apparently have even seen it back in May of 2025. Roughly 2 months before the official discovery, with this test data suggesting that the comet was already active, even at a distance of 6 astronomical units. And this is one of the more important discoveries because we don't expect comets to be active yet, especially when they're beyond the orbit of Jupiter. And so this very early outgassing, which in most comets happens much closer, suggested that this was a pristine object containing a lot of very specific ices that started to evaporate very quickly. And it actually increased in brightness quite fast, which essentially suggested that it was outgassing or releasing all of this gas much faster than most comets in the solar system. And researchers discovered that this was the result of hypervolatile materials such as carbon dioxide and carbon monoxide, which normally have a much lower sublimation point compared to what we usually find on comets, which is water ice. With this being a very important first hint, it suggested that comets from other star systems might of course have different composition to the ones we typically find in the solar system. With these suspicions officially confirmed when the James Webb Space Telescope observed this back in August of 2025. And so here on August 6, using the near-infrared spectroscopy, and at a distance of about 3.3 astronomical units away from the Sun, James Webb was able to capture the comet in a lot of detail, and most importantly observe its spectroscopy as well, with these first results being absolutely groundbreaking. First of all, it revealed that the comet here, or the fuzzy atmosphere surrounding the nucleus, was primarily made out of carbon dioxide. As a matter of fact, it was approximately 8 times more carbon dioxide compared to water. This was the highest CO2 to water ratio ever seen in any comet out there. Okay, technically there's another anomaly you see right there, the comet known as 2016 R2, with a period of about 20,000 years, but here it was eventually established that this particular comet seems to belong to a rare family of comets existing on the outskirts of the solar system, or could also be some kind of a fragment from a much larger Kuiper Belt object, such as a dwarf planet. And so it will be very exciting to see some kind of a study comparing these two comets because they're both very anomalous. But still, we know that these are comets, because James Webb also observed carbon monoxide, water, carbonyl sulfide, and specifically in amounts that we do expect from a typical comet. And so although there are some anomalies, for the most part, it looks like a duck, it quacks like a duck. So it's a comet. But what exactly does this tell us about this object? Well, because there's so much carbon dioxide, it may mean that the ices in this comet were exposed to much higher levels of UV radiation around its host star system. Or basically it came from a star that was maybe hotter and more massive, which dramatically changed its surface composition compared to what we have in the solar system. Another possibility is that it formed beyond the carbon dioxide line, so basically really far away from the star, and has never really seen any other stars, and was then somehow kicked out of the system without interacting with the star at all. As a matter of fact, it potentially did not interact with any stars, with the Sun being the first. But in order for it to get kicked out from such a faraway distance, it would either have to be some kind of a massive planet on the outskirts, or possibly this came from a binary system, where the two-star interaction might have affected its orbit. But on top of this, when it comes to the carbon isotope ratio, specifically measuring carbon-12 to carbon-13, which was also by the way visible here, it was discovered to be very similar to Earth, suggesting that its material was created in a very similar environment to the solar system, with very similar carbon species composition, and possibly even around a star system that's not too different from our own. But we also obviously have a lot of other observations with other telescopes, with additional observations from, for example, VLT, or the Very Large Telescope, also detecting something else. Here the researchers detected the onset of atomic nickel emission lines, and later on cyanogen gas emissions. And this is of course what this new study was about, and it was these nickel emissions that unfortunately caused Avi Loeb to once again start talking about aliens, which is why the researchers behind the study decided to reach out to me and highlight the fact that he seems to not understand what the study is about. And so let's discuss these nickel emissions and what it actually means based on the study. So here scientists did detect numerous nickel lines, but the iron emissions remained undetected. And here nickel is not unusual at all. It's been detected in atmospheres of a lot of different comets, or to be more exact, in approximately 20 different comets, as well as the previously discovered interstellar comet, Comet Borisov. As a matter of fact, there is one study you can find in the description that specifically talks about nickel and iron detected in a lot of different comets, with many heavy metals evaporating from these comets, but whose origin is still not entirely clear. As in, scientists are not certain why some comets have nickel, other ones don't, and how nickel can even get that far in a solar system. And so the detection here is particularly significant, especially because metals like nickel and iron require extremely high temperatures, usually over 700 Kelvin, in order to sublimate. But finding nickel in these colder distances around 3 astronomical units suggests that it's been efficiently released from low activation energy carriers, most likely via some kind of a photochemical process or photochemical reaction, or basically stuff on the surface of the comet reacting with the sunlight. And in this study, researchers do propose one potential candidate, nickel carbonyls. Incredibly volatile elements that obviously do contain nickel and can photodissociate pretty easily. And so in other words, they do provide a very reasonable scientific explanation using an actual element that we know exists in nature. But the mystery here is not nickel, it's why there seems to be no iron. The absence of detectable iron, which has been discovered in the solar system comets, means that iron carbonyls are possibly either less stable or don't form in these water-rich conditions as easily. Or basically, they either don't exist, have not formed on this comet, or maybe for some reason in this comet they just seem to be absent. And this is a really crucial finding because it challenges traditional understanding of how metals are released from comets, and also offers new insights into chemistry of distant star systems and their protoplanetary disks. Because here, for all we know, maybe for some reason, this star system is not enriched in iron, which actually would be super bizarre. And so here the production of nickel increased very steeply as the comet approached the sun, hinting that it was the heat that was suddenly releasing more and more stuff, but also obviously creating this new mystery that's somewhat challenging to solve right now. But in this case, this chemical mystery is not going to be solved anytime soon until we get even more analysis, or until we can actually compare this to some of the comets in the solar system. And especially comparing this to the comet you see right there, C2016 R2. And in some of the previous videos, we also discussed that it's quite likely this comet potentially came from the thick disk of the Milky Way. Based on its trajectory and based on the velocity, it possibly came from the region containing much older, low metallicity stars, anywhere from 7.5 to maybe even 9 billion years old, or possibly even older. And so here maybe its compositional mystery is somehow related to the ancient star it came from, as in maybe it just has a different composition because the star was much older and did not contain these same chemical elements. But because this comet is still approaching the sun, and also because it's actually going to disappear behind the sun for at least a couple of months, the research about this object is obviously still not finished. As a matter of fact, in the next few months, we're going to have additional observations, even from observatories and spacecrafts that are not even designed to observe comets. For example, NASA's SOHO, or the Solar Observatory, and the now famous NASA's Parker Solar Probe. And that's because these observatories are going to be able to see the comet behind the sun. And so as the comet passes through the fields of view of several solar observatories, it's quite likely that we're going to receive additional data, offering more opportunities to study its composition and its real-time behavior. But I guess before we finish, so what's the big takeaway right now, as of September of 2025? Well, first of all, we know that this is a very unique object. Pristine primordial remnant from another star system, possibly much older than the Sun, that seems to contain very specific signatures of primordial interstellar chemistry. And since it has this very bizarre composition, with the highly enriched carbon dioxide coma, and emissions of nickel but no iron, it also now suggests that the cometary material across the galaxy is not necessarily universal and is not necessarily the same. It seems to vary from star to star, and obviously we still have no idea exactly where this came from, or what kind of a star system it was born around. By studying this in more detail, we'll hopefully understand how these objects form, how they get ejected, and more importantly, understand how these objects exchange materials with other star systems, or possibly even seed planets like Earth. I mean, some of the stuff that's being evaporated right now, at some point might end up on Earth after all. And so understanding and studying this is obviously quite important. But honestly, I'm really waiting for observations from the now functional Vera Rubin Observatory, because chances are it's going to be detecting these objects left and right, possibly even finding one per month. And so hopefully here, by studying these objects, we can learn a little bit more about the effects from these comets on other star systems, and also maybe learn about the fascinating concept of panspermia, which has been suggested before. So can these comets potentially transfer life from one star to another? Hello wonderful person, this is Anton, and today we're going to discuss some of the recent updates about the most mysterious object in the solar system as of 2025, the by now famous third interstellar comet 3I Atlas. The comet that was officially discovered on July 1st of 2025, and a comet that astronomers have been racing to study because it's actually going to be almost completely invisible to us for several months, very soon. And so in the last few weeks, especially in September of 2025, we actually did have a lot of new studies and a lot of new observations, which means that we kind of have to talk about them again, because this comet is once again changing and is doing something nobody expected. But just so that we're clear, still no aliens, despite the fact that apparently it turned green. And we'll discuss why in a few seconds. And so here, based on the observations from the James Webb and the Very Large Telescope, along with the new observations from the Gemini South Observatory, we now have an even better understanding of what's going on here, but some of the initial assumptions about this comet have sort of fundamentally changed, because this is as unusual and as alien as comets can get. And it seems to be unusual both physically and chemically. And so today we're going to focus on some of these new studies, all of which, as always, you can find in the description below, and mostly focus on why this comet is just so different from anything in the solar system, and what sort of explanations we currently have for all of this, and what do we know so far. And so let's start with the coma and the activity itself, because that's really where most of the mysteries come from. And so here, just as a reminder, we know this contains a solid icy core, or a nucleus, surrounded by the fuzzy atmosphere known as coma. This is essentially what you see right there. And this is why it's sort of difficult to see the surface, because it's covering everything. And in all comets in the solar system, the coma itself usually forms when the object gets relatively close to the orbit of Jupiter, or approximately 5 to 6 astronomical units away from the Sun. And in general, this involves the process known as sublimation, or essentially the solid particles on the surface, instead of melting, just become gas. But the major mystery about 3I Atlas was its unusual activity that was really unexpected, because it actually became active much farther away, with the observations from the Gemini South in August of 2025 confirming that it's still growing and still emitting more and more stuff, which implied that it seems to possess the chemical makeup and the composition that we most likely have never seen before, because we don't expect things to sublimate so early for any of the comets we have here. And so by August of 2025, Gemini South Telescope captured a visible and very prominent anti-solar tail, or tail pointing away from the sun, that was at least 56,000 kilometers in length, definitely confirming that this seems to have classical cometary behavior. But interestingly, during the early August, they also noticed that some of the inner coma appeared to be slightly elongated and pointing toward the sun, so it basically had a kind of an anti-tail. But it was pretty quickly determined to be not a tail at all, and instead a dust plume being emitted preferentially from the sunlit side, where the dramatic heating of ice made it sublimate much more actively, essentially releasing a huge amount of dust toward the direction of the sun instead of away from the sun. And by early September, observations confirmed that the inner coma has now evolved into a fan shape, implying that even compared to comets right here in the solar system, this one here was evolving super quickly. And this constant change and these constant emissions gave scientists enough data to start making assumptions about its composition and the core itself. And while almost right away, based on the detections from the James Webb, it was determined to be a strange comet in terms of actual elements. First of all, it was incredibly enriched in carbon dioxide. Here the ratio of carbon dioxide to water was approximately 7.6 to 1. Much higher than anything in the solar system. And because we know carbon dioxide melts at much lower temperatures, this definitively explained why this comet became visible so early on. It essentially started to become cometary at much farther distances because it was mostly carbon dioxide, or at least its surface was mostly carbon dioxide based, with only a little bit of water. And this potentially implies that 3I Atlas may have been formed outside its parent star, or perhaps near what's known as the carbon dioxide ice line. It's essentially a line much farther away from the star, where temperatures are usually cold enough for carbon dioxide or dry ice to condensate and to form solid structures, because otherwise there's really no good explanation for why there's so much CO2 on the surface. And here it was also confirmed that the nucleus has a very thick insulating crust, very likely suppressing sublimation of water, and very likely causing water to remain trapped inside, which basically implies that it has somewhat bizarre surface structure. But at the same time, the Very Large Telescope in Chile was able to confirm two very specific elements that we usually do find around comets. It detected the cyanogen ions, or ions of cyanide, an atomic vapor of nickel. Now, as I mentioned in one of the previous videos, detecting nickel in this case is very common. As a matter of fact, a lot of comets out there usually emit nickel, so that by itself does not mean that this is a metallic object. But what is super strange is that we normally also expect the emissions of iron. And so even though in the solar system, in a natural comet, we do see both iron and nickel, here the lack of iron vapor is actually kind of bizarre, suggesting once again that it seems to have a different formation history from a typical comet in the solar system. With additional observations also revealing that this comet seems to lack a lot of carbon chain compounds, specifically compounds like C2 or dicarbon. And that's actually kind of important for what we're going to be discussing next, which is its change of color. And so because this was depleted in carbon chain compounds, which we do expect to see around comets, here this suggests that compared to comets in the solar system, 3I Atlas was extremely depleted in dicarbon compared to cyanogen atoms. Once again, not something we observe in the solar system, making this super bizarre, at least in terms of chemistry. But now, just a few days ago from when I'm making this video, a team of astrophotographers, Michael Jaeger and Gerald Remen, were able to capture the comet during a lunar eclipse over the skies of Namibia, with this incredible and very beautiful picture showing us something that currently does not make a lot of sense. As you can see, the comet seems to be green. Okay, so that's not unusual for comets, but usually this bright emerald green color is actually caused by dicarbons in a typical solar system comet. So basically, if we see green comets, it's because of the dicarbon atoms being ionized by the solar radiation and emitting green light. Yet, as I just mentioned, the chemical observations from just a few weeks ago discovered no bicarbon, establishing that this is a bicarbon-poor comet and thus should not be able to produce these colors. And so at least as of today, spectroscopic observations suggest that there is no dicarbon at all. Although here I have to mention something really important that's been circulating on the web and unfortunately has been kind of misrepresented by Avi Loeb, that Harvard guy. In one of his recent blog posts on Medium, he essentially tries to explain this color as the emission of cyanide that was confirmed around the comet. And the thing is, well, that's actually kind of incorrect. As a matter of fact, I believe it's very incorrect. I'm actually going to post a link for this older paper from 1994 that specifically talks about this, but for some reason some articles and some websites, and of course Avi Loeb's post, seem to claim that cyanogen emits green light. However, cyanogen emits mostly violet light at 387 nanometers. As a matter of fact, it's almost ultraviolet emissions, and though it does have some weak emissions at 420 nanometers, and the infrared as well, it does not produce any green light at all. And so at the moment it's actually unclear how all of this started and why so much press picked up on this, but for typical comets, cyanogen does not contribute to the green color, as you can learn from the study in the description. And as a matter of fact, the study is called The Cometary Fluorescence Spectrum of Cyanogen. So like literally the entire study is about the colors. And so the reality right now is that nobody knows why exactly it's green, but that's of course part of the exciting mystery. Because this is such an unusual object and because it's from a completely different star system, we do expect it to emit some really strange things. With the other mystery coming from a slightly different observation in regards to its polarization. With the idea of polarization referring to the light waves wiggling in all directions instead of wiggling in a single direction. And so here, based on the Nordic Optical Telescope, the additional observations from the comet revealed that it's characterized by an extremely deep and narrow negative polarization branch, which is very strange for comets and asteroids, and even previous comets like 2I Borisov or comet Oumuamua. And so these negative polarization effects suggest that the dust coma is made from a unique mixture of icy and dark materials, with some of the lab experiments showing that a thin frost layer of water ice covering dark surfaces could maybe produce polarization measurements similar to 3I Atlas. Although something somewhat similar has been observed from very far away objects, such as trans-Neptunian objects, like for example objects like Pluto and its moon Charon. And intriguingly, in one of the recent studies about the first interstellar object, Oumuamua, a team of scientists provided enough evidence to suggest that Oumuamua might have been some kind of a Plutoid chunk or a fragment of a Pluto-like object from a different star system, because of its very strange characteristics and because of its pure nitrogen ice composition, and even its pancake shape. And so it would not be strange that we actually have something very similar here as well, with this object also coming from some kind of a faraway region in a different star system, and possibly also being a chunk of a dwarf planet, or some other chunk of ancient ice from an object far away from the star. But one question we still have no answer for is, of course, so where exactly did this come from, and how old is this? And that's because currently it's impossible to trace where the comet came from, but one of the recent studies that was just published in September used the data from the famous Gaia telescope to try to reconstruct its trajectory, and essentially discovered that in the last 4 million years it did not approach any major stars, and seems to have traveled completely undisturbed for a very long time. Now, beyond 4 million years we don't really know because the trajectories become very uncertain, but this once again confirms that this is very likely a pristine object. But because it's moving so fast, and because of its relatively unusual trajectory, it's still assumed to be a really old object, possibly billions of years older than the solar system, but even that is no longer certain. As a matter of fact, at least one recent study does suggest that this is maybe a little bit younger at 3 billion years, and not 7 as proposed before. And so in terms of the origin and the age, this is not a question we're going to be answering anytime soon. But apart from the green color discovery, there was also something else that we do see in other comets, but in this case something once again a little bit more extreme. The observations from August and September revealed an unusual shift in the comet's color profile. Initially it appeared to be red, which indicates light reflected from the reddish surface, very likely oxidized for billions of years by cosmic ray exposure. But around mid-August of 2025, the color quickly changed and transitioned to something we usually see in the solar system comets. And right now scientists think this is because of a shift from the red particles from the crust that started to be overwhelmed by white grains of ice coming from the surface. So basically here we had separate emissions at different times, and mostly because the comet started to warm up with more and more stuff coming from the surface. Okay, we've discussed the composition, the observation of colors and so on, but what's next? Well, there's actually something exciting that's going to be happening in the next few days that a lot of scientists are trying to capture. According to the projections in late September, this comet is on course to be struck by an extremely powerful coronal mass ejection, or basically a kind of a solar burp that on Earth usually produces the aurora. And this high-energy event is expected to provide scientists with very unique insights into what happens to interstellar ices and dust when these bursts of solar wind and radiation start to interact with it. And so they actually want to see what happens to the tail and the coma, and how this affects the color change as well. As a matter of fact, because of these interactions, we might actually see some of the stuff that was not seen previously, because it's now going to be reacting with all of this solar radiation. And so chances are in the next few weeks we're going to hear more about this comet, until it finally disappears behind the sun in October of 2025. But we might also hear back from the Martian missions, because around early October they should be able to see this comet as well, and might actually collect more data. That's once again because around this time the comet is going to be very close to Mars. And so until November and possibly early December, we're not going to hear much about this, just because it's going to be behind the sun. But once the comet becomes visible again, this is going to be super exciting, because we'll get to see how it changed, and we'll get to see what's actually hiding behind all of this bizarre ice on the surface. And we'll also get to see some of the thicker layers underneath the crust, assuming of course the comet survives the passage and does not fall apart. And so this is definitely one of the most exciting events in 2025, and a very exciting object to study, just because we've never seen anything like it in the solar system. Not only is this different from the solar system comets, it's also different from the two previous extrasolar comets that did not show any of these emissions. And so as astronomers continue to watch this, and as they continuously gather more information, we'll just wait and see what happens, and we'll definitely come back and discuss this more in one of the future videos very soon. Hello wonderful person, this is Anton, and today, once again, we're going to be discussing the third confirmed interstellar comet, 3I Atlas, a real-life cosmic visitor from another star system, carrying all sorts of mysterious secrets with it. But, well, if you've seen the movie Don't Look Up, and honestly, I guess who hasn't at this point, you probably remember the central premise. There's a massive extinction-level comet that's headed toward the planet, and absolutely nobody in the media or the public cares. That's why it was called Don't Look Up. Everyone is too busy looking at, well, everything, except for the massive rock that's about to end civilization. And when Comet 3I Atlas showed up, I thought that, well, here we go. We finally have an opportunity to, I guess, prove those Hollywood writers incorrect, because we're going to be super rational, we're going to look up, and focus on actual verifiable science that's going to tell us a little bit more about the galaxy, and make us just a little bit smarter. Yeah. So that hasn't actually happened. And though we are looking up, which is of course the good news and something we're going to be discussing today, the bad news is that the public dialogue so far is a little bit disturbing. Here the public dialogue is stuck in a kind of a perpetual loop, resembling a poorly written sequel to Don't Look Up, unless it's alien tech. And that's because of one single person from Harvard who a lot of scientists are really upset with, and because of one controversial paper, poorly written paper by the way, that decided to hypothetically ask, well, what if this is an alien tech because of all of this metal emitted from it, such as nickel. We'll discuss this in a few minutes. Suddenly, the only thing anyone wants to talk about is whether this giant dusty space snowball is actually a flying saucer piloted by some kind of a weird civilization trying to communicate with us. But if you're here for that, sorry, we're not going to be discussing this. Because today we're going to be discussing the actual science, and all kinds of reports showing the extreme nickel to iron ratio, the unusual observations in regards to water emissions, and some other really cool scientific stuff that tells us so much more about this comet and the galaxy, and not really about aliens, or whether they even exist. So today, we're going to focus on science once again, because the comet has once again been captured by another spacecraft, and we now have even more data. Let's dive into the real science of 3I Atlas. And as always, all of the studies I'm going to be mentioning today, and all the previous studies we discussed, should all be in the description below. But in case you're bored with the video and just want to move on, but one day would like to find out more about the comet and actual science behind all of this, here's how I do it when preparing for these videos. I go to a website called Archive. This is a free-to-use website that contains all of the initial drafts for all of the studies in astronomy and astrophysics, and is run by Cornell University. Here, by typing 3i Atlas in the search box, you basically get pretty much all of the major studies about this, which you can then read to your content. But if you don't want to read them, I mean, this is what this video is for. And so, following this super long intro, let's talk about the comet. Discovered relatively recently, in July of 2025, and almost instantly confirmed to be an interstellar object because of its very stretched, hyperbolic trajectory. Or basically because it was moving so fast across the solar system that there is just no way to explain this unless it came from somewhere far away. The initial velocity was 58 km per second, but it obviously has already increased by now because it's approaching the sun. But the reason this became so exciting for astronomers, and actually a lot of other scientists, is because of its very unusual composition and extremely unusual activity that forced scientists to start rethinking about what we know about comets around other stars. And so in the last month or so, as the comet approached the sun a little bit closer, and as it actually approached Mars, we've now collected even more data, but also answered some really important questions. But I guess first let's recap what we know so far from some of the previous discoveries in the last 2 months. First, we know for sure that this is an active comet. And it's a comet consisting of solid icy nucleus surrounded by a fuzzy cloud of gas. And so it actually does look like a typical comet we observe in a solar system. But the nucleus is potentially a little bit smaller than we initially thought, maybe about 5.6 kilometers wide or even smaller. Initially this was thought to be much larger at 20 kilometers, but the observations from the Hubble Space Telescope corrected some of these initial assumptions. It's also believed to be pretty old, possibly over 7.6 billion years old in age, because it seems to have come from the location in the galaxy that contains a lot of ancient stars, which may explain why its chemistry and its composition is just different from what we have here. And in terms of composition, some of the early observations from the James Webb Space Telescope confirm that this comet is incredibly enriched in carbon dioxide, and especially enriched in CO2 compared to water. And for the solar system, this would be super weird. We don't really have comets that are so enriched in CO2 and so depleted in water. Currently, the ratio is the highest we've seen in any comet, making this a somewhat exceptional object. But for scientists, this is also a really important hint. The hint in regards to the formation of this object. It very likely formed in a very cold environment, where CO2 can condense pretty easily, and very likely got kicked out from the outskirts of its star system, carrying all of this pristine material for billions of years. With these same observations also discovering a lot of other stuff we usually observe in comets, including ions of cyanide, carbonyl sulfides, and carbon monoxides. None of these are strange. A lot of comets in the solar system contain them as well. And so here it was really that water mystery at first that was a little bit strange. And we now potentially have one of the solutions. Because recent discoveries did actually finally find water, but in a very strange way. In a study published in late September, scientists using the NASA Swift Observatory detected the first clear evidence of water molecules. But they could not see water directly. Instead, they discovered what's known as hydroxyl gas. Hydroxyl is a leftover when sunlight breaks down water molecules in outer space. And there was a lot of it as well. And this was a major discovery and a major technical achievement. Now normally from Earth we cannot actually see this because this can only be visible with the ultraviolet detections and the UV light is blocked by the atmosphere. And so ground-based telescopes cannot see this. But the Swift telescope could. It's a space telescope, so it was able to detect the signal pretty easily. But the mystery was in regards to when this was detected. It was actually seen back in July of 2025, when the comet was at least 3 astronomical units away from the sun. And we don't expect water to evaporate at this distance from any cometary object. Water usually starts to evaporate much closer. Yet here, researchers confirmed that the water was escaping the comet super fast, 40 kilograms per second. Here scientists even compared this to basically a fire hose running at full blast. And so the explanation now suggests that all of this water was not coming from the direct sublimation, but was actually part of much smaller ice-coated dust grains that were ejected into space and contained water on the surface. And the water was then broken down by the sunlight, producing all of the hydroxyls. And so the water vapor was not released directly from the comet, but from the escaping dust instead. And this is a really important discovery and a very important benchmark for comparison, because we obviously have 2 other interstellar comets to compare this with. The first comet, Oumuamua, was completely dry. It contained no water. Comet Borisov was rich in carbon monoxide, but the water was not a significant discovery. Yet here we have a surprising amount of water, but at an unexpected distance. In essence showing us how diverse the building blocks of comets across the galaxy seem to be. all three of them seem to be almost entirely different. And that's once again not really what we expect, because we always thought that maybe comets were kind of similar to what we have in the solar system, as we expect all of these star systems to form in a very similar way. It looks like maybe that was a premature assumption. Then we have our metal discoveries, and that of course created a lot of buzz in the press because detection of nickel coming from the comet somehow convinced the press to think that maybe this was the spaceship made out of metal after all. But the reality is that there are dozens and dozens of cometary studies that always find iron and nickel in pretty much most of the comets in the solar system. As a matter of fact, many comets we observe pretty much every year seem to contain at least some of these metals, and we are pretty certain none of them are aliens. Nevertheless, there was a bizarre mystery here as well. Mostly because in the solar system, the ratio of nickel to iron is usually very specific, but is also about 10 times higher than the ratio discovered in the Sun. So essentially we see these metallic particles, but we're not entirely certain why the ratio is so different. And so some of the recent observations from the Very Large Telescope tracked the comet between August and September and confirmed the discovery of nickel emitted from this comet as well. But at first they didn't really see any iron. And that was of course a big mystery, because why not? We actually always expect iron and nickel to kind of come hand in hand. And so this lack of iron was somewhat difficult to explain. But it did appear just a little bit later. Once the comet was closer to the Sun, about 2.6 astronomical units away, we suddenly started seeing signs of iron as well. And you can kind of see the evolution of these spectra in this image. Here nickel, which is solid blue, and iron, which is visible in red, dramatically changing its emissions over time. And so this extremely high nickel to iron ratio dropped extremely fast as the comet got closer to the Sun. And though the iron-nickel emissions resemble the typical solar system comet, this unusual rapid change is something new and something that's never been seen before. But it does provide support for at least one potential explanation when it comes to comets: the theory of metal release. And specifically that these metals are contained in a highly volatile organometallic compounds, specifically nickel tetracarbonyl and iron pentacarbonyl. So they're not just pure nickel and pure iron, they're actually organic compounds. And so in this case, nickel tetracarbonyl has a lower sublimation temperature, and so it starts to emit much faster, whereas the iron molecules vaporize much closer to the Sun and thus are usually invisible farther away. And so here this comet provided us with at least some evidence, or at least some explanations, for why we seem to see iron and nickel emitted from comets even right here in the solar system. They're essentially just part of a very specific organic compound. But additionally, on October 3rd, as the comet made its closest approach to Mars, and it was only about 30 million kilometers away from Mars, the European Space Agency used one of its orbiters, ExoMars, to try to snap a picture of the comet as it moved across the night skies. And that's what you're seeing right here. And when it comes to the orbit, here's roughly when this happened. So as you can see, Mars and the comet were pretty close to one another. And so here 3I Atlas is seen as a fuzzy bright dot representing the comet's icy nucleus, surrounded by a coma thousands of kilometers wide. But as you can see, the images are not particularly exciting because these observations were sort of challenging. This comet is about 10,000 to even 100,000 times fainter than the Martian surface. And this particular probe, or this orbiter, is not meant for these types of pictures. And so because of the distance and the faintness, the orbiter was unable to distinguish the nucleus from coma, or even capture the tail. Mostly because they were designed to look at Mars and the Martian surface, not really the comet. But looking ahead, as the comet travels across the solar system, there are maybe two other deep space missions that could maybe observe it again. Since this comet's trajectory aligns with the ecliptic plane, the Europa Clipper and ESA's Hera spacecraft may potentially pass directly through the comet's Ion's tail in the next few weeks. So here we're talking about November 2025. And while they're going to be millions of kilometers away from the cometary core, by crossing the tail itself, it would allow Europa Clipper, which has a plasma instrument and a magnetometer, to potentially detect signatures like the magnetic field, or to pick up ions from the interstellar object for the very first time ever. In other words, there's a very high chance we might get some data from this particular mission, even though, once again, it was never designed to look at comets. Likewise, the European Space Agency's JUICE mission, or Jupiter Icy Moons Explorer, is now scheduled to observe this object on November 2025 as well. And at this point, because the comet is going to be very close to the Sun, it's expected to be very active. And so the spacecraft is going to observe the comet with every single instrument it has, but we're not going to get the data until early 2026 because this spacecraft is also going to be behind the Sun, so we're essentially just not going to see it for some time. And as I mentioned in previous videos, for the next few months it's just going to be invisible to us because of its position behind the Sun from the perspective of planet Earth. Even based on the data so far, this is already one of the most exciting objects in the solar system, and it already started to rewrite certain understanding we have about comets and other star systems. Once again, for example, the detection of the water vapor at such great distances currently challenges traditional understanding of cometary activity, and even suggests that sometimes tiny ice-coated grains can form much farther away from the Sun than we expected, producing very bizarre tails surrounded by water particles. Furthermore, the dramatic change of nickel to iron ratio supports the idea behind the volatile organometallic compounds that many of these comets, even the ones in the solar system, seem to be made out of. And so many heavy metals we observe in cometary tails seem to be produced the same way. And so the ultimate importance of this comet and the observations right now are really all in regards to the composition. It offers us an extremely rare opportunity to study the chemistry and physics of different star systems and try to understand stellar formation by observing these pristine materials. And though right now there are still quite a lot of unanswered questions, I think by now it should be pretty clear that none of them should be about whether this is some kind of an extraterrestrial probe or if there are any aliens on board. And that's because there is literally zero observational evidence that something bizarre is going on, except for that unusual chemistry I mentioned in the video. Hello wonderful person, this is Anton, and well, it's time we've talked about 3i Atlas once again. We do have some updates and some new discoveries. And in case you have no idea what I'm talking about, it's of course this. The third ever interstellar object, or interstellar comet, discovered back in July of 2025, that scientists have been rushing to study for the past few months. And well, right now the comet has just completed the most intense part of the journey. It passed through its perihelion, or the closest point to the Sun. But unfortunately for us, for this crucial period, it was entirely hidden by the Sun and was only visible from planets like Mars. We've actually discussed the observations from Mars in one of the previous videos in the description. But I mean, just in case you're curious, there was not much to see. But despite of this, a lot of space-based instruments kept their eyes completely locked on this comet, just because this is such a rare event. But now that it's re-emerging from behind the Sun, researchers have a new chance to observe it once again, and we do have some of the first discoveries already. But today we're not really rehashing some of the older facts that as always you can check out in some of the previous videos in the description, and we're not discussing any basic facts. So for example, speed, size, age and so on, all of this was mentioned before. Instead, we're just focusing on some of the most recent updates, and specifically updates that might be a little bit unexpected, and updates that reveal the true nature of this object. But a lot of these discoveries are obviously super exciting just because of how old this comet is believed to be. At 7 billion years old, or possibly even older than that, this is literally a time capsule. It's now releasing material that's billions of years old, giving us unprecedented insight into the ancient history of the galaxy. But what exactly happened during the perihelion, or the closest approach to the Sun? Well, this officially happened on October 29th, or basically just a few days back, and at this point it was about 130 miles or 220 million kilometers away from the Sun, so actually just a little bit farther than planet Earth. And since the comet was hidden from Earth, researchers had to use space observatories such as SOHO and GOES-19. These observatories were perfect because they generally are designed to block the sunlight, because their main mission is to study the solar atmosphere. And so they were able to observe this particular comet and did discover some intriguing facts. And the first discovery here was right before the perihelion. This was like October 20th to 25th. During this time, 3i Atlas underwent a rapid and dramatic brightening. It basically became brighter than ever before, and I think from Mars it would have been absolutely spectacular to see. But this surge in brightness was much steeper than usually seen in most comets, which normally brighten much slower as their ice turns to gas, with one analysis calculating that the brightness increase was so dramatic that here the proportionality was inverse to the distance with the power of 7.5. Or just to rephrase this, something really bizarre was happening on the surface. This was officially reported in this study you can find in the description. But because this is a completely new discovery, nobody has any idea why this happened. We just know that it seems to have dramatically increased its gas emissions as soon as it got closer to the Sun. But on top of this, observations have also revealed that the comet seems to be much bluer than the Sun itself. And this is quite a significant discovery because there is a dramatic color shift from what it was like before. Here it essentially indicates that a lot of volatile molecules such as cyanogen, and possibly ammonia, were now contributing substantially to the visible light. And so here the strong glow from all of these gases was enough to overpower the typically reddish light that's reflected by the dust. And moreover, this is of course the third color change, because before that the comet was also green for at least a few weeks. The video in the description discusses this a little bit more, and by the way, why it was green is still not entirely certain. And so here the observations once again confirm that this comet was intensely active during the flyby, shedding the material way more than a typical comet in the solar system. And this potentially confirms that this is indeed an ancient object that's never actually seen any star before. It was very likely formed on the outskirts of an ancient star system and spent billions of years in complete darkness, which is once again why this comet is so exciting. Here's another really exciting image from the Very Large Telescope, showing us how the comet changed over time and how it even produced an unusual plume facing the sun. But we also have some additional observations and some additional discoveries coming from the observations by the James Webb. Here, by seeing this comet in the infrared, it was once again confirmed that this comet has been extremely irradiated. Or essentially, during its lonely journey for billions of years, it was constantly bombarded by galactic cosmic rays, with this extremely long exposure fundamentally changing the materials on its surface through an extremely slow chemical process that took billions of years, which resulted in the development of a very thick and difficult to penetrate crust that was estimated to be anywhere from 50 to 65 feet or 15 to 20 meters deep. And so had we actually landed on this comet when it was still far away from the sun, we would have actually found ourselves on a very bizarre object containing super ancient crust produced by the interaction with the cosmic rays. And this irradiation process explains one of the comet's earliest unusual chemical detections, which you can also see in this graph. The extreme levels of carbon dioxide enrichment that was actually kind of difficult to explain at first. And so here billions of years of interactions of carbon monoxide with the cosmic ray radiation as the comet traveled across the galaxy resulted in all of this carbon monoxide turning into carbon dioxide, which is why it was observed in such huge amounts. And for astronomers, this is actually a bit of a paradigm shift. It just taught us something new. It means that the gas and ice we see venting from comets, in most cases, seems to be processed material, usually a product of extremely long journeys, with the surface interacting with the cosmic rays for a very long time. And so it's not actually pristine material after all, and very likely different from the material that produced the original star system. So here we're talking about something that has been chemically modified for a very long time. And in this case, if scientists want to find clues about its birthplace, here we would have to hope that some of this intense solar heating during the perihelion was strong enough to potentially erode some of this external crust and expose some of the untouched ice or primordial ice underneath. So right now we don't really know exactly what we're going to see. Nevertheless, 3i Atlas still offers us unique information, including, as I mentioned previously in one of the videos in the description, slightly higher levels of nickel compared to the comets in the solar system. And so here we have at least some hints on what some other star systems might be made out of, but obviously nothing concrete yet. But then there was another study that proposed something really intriguing in regards to these comets. So basically here the question is, why is studying these interstellar comets even important? Well, here it might challenge our understanding of how planets may form. And that's because in the standard model of planet formation, usually dust and small particles stick together to eventually form planetary bodies. But here in this proposition, there's this one small problem. It's referred to as the 1 meter barrier. Once objects reach about 1 meter in size, they tend to bounce off and shatter upon collision instead of sticking together, which of course raises a question. How do planets form then? And some of the recent models suggest that a lot of interstellar objects, due to their omnipresence in space, could potentially be gravitationally captured by some of these dusty disks around young stars, and then potentially act as a kind of a foundation for a new planet, or basically act as a kind of a seed onto which other material can then suddenly start building up. And this is actually crucial because in this case, it dramatically speeds up planetary formation process, with this particular bizarre capture mechanism potentially explaining why some of the larger planets like Jupiter seem to be found more commonly around stars much more massive than the Sun. In this case, the higher mass star is simply more efficient at capturing these interstellar objects, and thus is better at forming large planets. But for now this is a hypothesis, even though it does explain one major problem with planetary formation models. Without actual simulations and without observations from somewhere else, it will be difficult to prove this. Nevertheless, if this is correct, it means that even planets like Earth potentially formed when 4.5 billion years ago some kind of an interstellar comet approached the Sun a little bit too close and essentially served as the seed for the formation of our own planet. But when it comes to additional observations, well, technically they're all going to start now. Now that the comet emerged from behind the Sun, the second phase of observations is going to begin. And the first post-perihelion viewing was right here. This is during Halloween, captured by the Lowell Observatory's Discovery Telescope. Now it still looks like comet and obviously not some kind of an alien spacecraft, so that's the good news. But the much better news is that it should now be also visible to even amateur telescopes in most of the locations in the northern hemisphere. And though it's still going to be kind of difficult to see, appearing as a kind of a visible smudge, usually in the morning twilight, as the comet moves northwards, it will actually become slightly easier to see, which means that we're going to get more and more images in the next few weeks. And so right now a lot of different space telescopes and ground telescopes are trying to conduct as many observations as possible. So here we're talking about both the Hubble and the James Webb, solar observatories like SOHO and Punch, and even interplanetary missions like Lucy and Psyche. These missions are going to be passing through the cometary tail, and so they're going to be providing some of the chemical data in the next few months. But some of the most exciting opportunities are going to be in approximately 1 month from when I'm making this video. That's because 3i Atlas is going to make its closest approach to our planet on December 19th. And so during this time we're probably going to get a lot of different pictures and a lot of additional footage. And hopefully around the same time, we'll also get some data from the Clipper mission that's going to fly through and hopefully collect some of the samples from the cometary plasma tail and return the data for scientists to analyze. And well then, by March 2026, it's going to be already near Jupiter. At this point it's going to be practically impossible to see, and because it's moving so fast, it's never going to return. And so right now we only have like a couple of months to collect as much data as possible, because as soon as it's far enough, it's no longer going to be visible. But based on all of these observations, it once again confirms that this is a really bizarre and very unexpected comet. For example, just the fact that it changes colors 3 times and dramatically brightened near the Sun is already kind of difficult to explain and will require additional studies and additional data that we just don't have right now. On top of this, the discovery of the irradiated crust, that's at least several meters deep, fundamentally shifts how we should be analyzing these objects, because it's not really primordial crust and has been formed by billions of years of exposure. And so this comet is not just an amazing sight, this is one of the most exciting objects to visit the solar system in the last decade. But here we do have to get comfortable with the idea known as negative capability. Basically being comfortable with uncertainties, mysteries, and possibly never actually having all of the answers. Since we only have a couple of months left to study this, there's a chance that some of these questions will never be answered at all. Hello wonderful person, this is Anton, and well, it's time for 3i Atlas update. The comet that we discussed quite extensively in some of the previous videos in the description, and the comet that's now finally visible again because it has now left the region from behind the Sun and is slowly moving away farther and farther until one day in the future it basically leaves the solar system once again. And well, if you watched some of the earlier videos, you probably already know that this is a confirmed third interstellar object with the estimated age of at least 7.4 billion years, and has already shown us quite a lot of very bizarre and difficult to explain emissions. Something that we're going to be discussing today again, because some of these emissions have been observed once again, and we actually do have some really cool discoveries, including the first detection of radio waves, which despite some press claims was obviously not produced by aliens, but by something much more mundane. But before we discuss this comet, I actually wanted to briefly mention something else, because press has now started to make a lot of claims about comets that are completely unrelated just by mistake. And first, this object. Mostly because some of the press articles started to claim that the comet 3i Atlas broke apart. And while the comet Atlas did break apart, but it's not the same comet. This one is known as K1 Atlas and is an entirely different object discovered by the same telescope referred to as Atlas. And well, that's the one that broke apart near the Sun. And so if you actually want to read about the other comet, C2025 K1 Atlas, the link is in the description. And here's actually a really beautiful image of this comet, captured by Dimitrios Kativainis. And then we also have this object, Comet Borisov, C2025 V1 Borisov, naturally discovered by the same astronomer who discovered the second interstellar comet Borisov as well. And this one was exciting because it was assumed to be almost interstellar, but just wasn't. There are some minor similarities in the orbit between these objects, but they're still entirely different objects, and you can learn about this one in the link in the description. But just to summarize, these are not related objects, and these two other comets are coming from the outer solar system and not from the interstellar space. As a matter of fact, they resemble every other comet we've seen so far. But when it comes to the 3i Atlas, well, the real discovery here is really in regards to some of the recent analysis in terms of the emissions coming from this object, and the core scientific consensus that's emerging that the data collected by telescopes like the James Webb and even the orbiters around Mars seem to all suggest that this is not really the pristine messenger we were hoping for. We've actually briefly discussed this study in the previous video, but in a nutshell, in the last few weeks, most of this new research seems to actually suggest the same. All of the information gathered about the surface of this comet seems to be fundamentally altered, or basically overwritten by billions of years of exposure to the galaxy itself, and the stuff we're seeing being emitted is not ancient material from the star system itself. And this is not just an interesting discovery, this is a very important paradigm shift. It basically suggests that many interstellar objects, like this one, have been dramatically altered by the radiation from outer space, the cosmic rays, and do not really show us the true picture of the original star system. And so even though astronomers were hoping that the analysis of this comet would actually tell us about what kind of a star system it might be, which might even help us discover where it's located, what they seem to have discovered instead is that this is unlike any other comet we've seen. Here the spectroscopy, which focuses on analyzing the light, specifically focusing on the Sphere-X mission and the observations from the James Webb, pretty much definitively confirmed that the material that's coming from here has been pretty bizarre. But exactly what does this mean? Well, first of all, the amount of different molecules that was detected was entirely different from what scientists expected to find. For example, one of the first discoveries was the extreme enrichment in carbon dioxide. As a matter of fact, when comparing the emissions of carbon dioxide to water, for this comet the ratio was 7.6, basically 7.6 times as much CO2 as H2O. But why is this a major discovery? Well, because in a solar system we never see these ratios. In a solar system the ratio is practically the opposite. It's something like 0.12, which means that comets usually produce way more water compared to CO2. And this means that this is, for some reason, the most carbon dioxide enriched object ever recorded. But it's not just CO2, it's also carbon monoxide, CO. Here the ratio is not as high, only 1.6, but still higher than expected. And so because of this unusual dual enrichment in carbon monoxide and carbon dioxide, at first it made absolutely no sense because we don't really expect to see this from any star system anywhere out there. We don't expect any planetary disk out there to contain anything similar. On top of this, the comet was also ridiculously red. In essence, some of the more recent observations that tried to analyze the color spectrum discovered that it seemed to have a very specific red spectral slope, making it one of the reddest small bodies known to us. Now, because we've seen something very similar in the outer solar system, and because we generally know how this forms, scientists were then able to create models and explain these anomalous properties as a result of a major transformation by GCRs, galactic cosmic rays. Or just to rephrase this, extremely high energy particles constantly striking this comet for billions of years very likely converted carbon monoxide into carbon dioxide and actually created this relatively thick layer of approximately 10 to 15 meters that's entirely different from what it used to be when the comet just formed. And this was then confirmed by various lab experiments when researchers tried to replicate galactic cosmic rays striking ice and discovered that it was also turning red over time. In this case, it turns red because of very specific organic molecules. And so with time, the synthesis of these very complex organic-rich crusts covers this whole object with this very red and super thick crust. And in some sense, it kind of starts resembling a very dark red walnut. But crucially, the recent calculations of the comet's erosion during the passage through the inner solar system show us that the material lost before it reached the closest point to the Sun only involved approximately 1 meter. And that means that everything we observed so far originated predominantly from this galactic cosmic ray processed crust. So essentially we have not seen any pristine material yet, and may not even see it unless for some reason the comet breaks apart and reveals what's inside. And for astronomers studying comets, this is profound. It means that the effects of this very long journey basically tell us about the chemical reactions across the galaxy and not the pristine ices from the birth of a star system. So essentially this is a really good example of what happens to objects if they travel through space for a long time, but just does not tell us much about other star systems. But at least we got some really good pictures from a lot of different probes. For example, here's a recent picture from the Tianwen-1 mission by China from a distance of about 29 million kilometers. And here's one of the more recent pictures released by NASA, captured by the NASA's Mars Reconnaissance Orbiter, that shows us both the trajectory of the comet and tells us a little bit more about the size of the coma. And in this image we see something entirely different. Here we see hydrogen atoms from 3 different sources that were captured by the MAVEN spacecraft back in September of 2025. And here we're actually looking at ultraviolet emissions, but as you can see, one of the emissions is coming from Mars. And so it's actually 3 separate things: the comet, interplanetary hydrogen, and hydrogen from Mars. All 3 are emitting a little bit of ultraviolet. But I guess one of the more exciting observations was this: the detection in radio waves. This was the first radio signal detected from the comet by the Meerkat radio telescope. And here this once again confirmed that this is a cometary object. Not that we needed this confirmation, by the way. And that's because the telescope was able to detect very specific radio emissions coming from here that were created by hydroxyl radicals, or essentially leftovers from water molecules. These are natural products of water molecules breaking down from the sun's UV light, and is a classical sign of an active natural comet. And so here this detection helps us put to rest a lot of speculations, and of course helps us learn a little bit more about its composition. But right now this was just a detection and not a calculation of anything specific coming from the comet. And so basically here we just know that it emitted very similar radio emissions to other comets, but not how much. On top of this, some of the observations from the European Space Agency have now achieved a major victory in tracking the cometary path. By using the data from ExoMars Trace Gas Orbiter, they were able to triangulate the position of the comet with so much precision that they can now predict its trajectory with a 10-fold accuracy. And this will definitely help us establish its pathway in the future, and more importantly will help us track it better with some of the future telescope missions. By combining all of these telescopes and by having them work together, this actually also serves a very important purpose that was not clear until now. This was an exceptionally valuable test case for planetary defense, being able to use a lot of spacecraft that were not even designed for tracking asteroids and comets in order to conduct precise astrometric measurements and in order to find out if any object out there may potentially strike our planet. And because all of this was done so quickly and only took a few weeks, this actually proves that right now we have enough technology to predict the path of any potentially dangerous object before it even comes close to hitting the planet. And by the way, if you actually want to learn more about planetary defense, check out some of the previous videos on the DART mission, or that time when NASA collided an object with an asteroid, to see what happens in one of the links in the description. But the key scientific question now is, well, what actually happened to the comet when it passed close to the sun? And was the intense solar heating enough to cause the erosion of this very thick cosmic ray crust? And if it did, then we now might start seeing some of the more pristine material coming from inside, which will be absolutely crucial in order to learn more about the star system. And even though some of these ESA spacecraft, such as the Jupiter Icy Moons Explorer, did pass through the cometary tail and collected some of the data, unfortunately we're not going to get that data back for at least a few months. Right now, scientists expect that the data will be returned in February of 2026. But since we also now have Vera Rubin Observatory that just became operational, we expect to actually see up to 70 such objects every single year, assuming the predictions are correct. And so for all we know, maybe next year in 2026, none of this is actually even going to be unusual. These are going to become very common objects, and scientists will be detecting them pretty much every single week. Nevertheless, 3i Atlas has redefined what we thought about interstellar objects, and has definitely helped astronomers to test all of the tools we have. Not to mention that we now also have this new hypothesis referred to as GCR processing hypothesis, which suggests many of these objects are probably covered in this bizarre crust, and also created a lot of collaborative opportunities for NASA, ESA, and other international teams to track and analyze this object together by using top-of-the-line space surveillance and planetary defense systems. So in that sense, this was actually absolutely groundbreaking. But obviously the observations are still not done, and we're still going to be discussing this quite a few times, as this comet is slowly speeding away from the sun and as it hopefully opens up and reveals something else. But by then we might actually find more interstellar objects and might even have new data to compare this with, allowing us to see how these objects actually differ. And so hopefully by next year the story here is going to become not really about alien spacecraft or green men trying to visit our solar system, but about slow, dynamic and powerful forces of physics that shape every piece of matter in the galaxy. And it's really because of objects like this that we're going to be learning more about what happens out there outside of the solar system. Hello wonderful person, this is Anton, and it's time for our 3i Atlas update right before the end of the year. Because just now, on December 19th, 2025, when I'm making this video, the comet has officially completed its closest approach to planet Earth, and quite a few telescopes were able to capture new images and reveal just a little bit more about this somewhat bizarre object. And here's actually a really cool compilation of 6 separate pictures from 6 separate observatories, showing us this comet in completely different light. And in case you were wondering, nope, still just a comet. Despite being green, this comet does not contain any green men. And so, as we reach the end of 2025, after just 6 months, this object has already provided a wealth of data, dramatically changing our understanding of what interstellar comets seem to be and how chemistry outside of the solar system seems to work. Oh, and by the way, right here, it was actually still pretty far from Earth. The distance here was about 270 million kilometers, or approximately double the distance of Earth to the Sun. But that was close enough for a lot of these telescopes to capture new data, with some of the most exciting images coming from the Gemini North Telescope. This was released only a few days ago, but here we have a kind of a comparison of the before and after image using exactly the same telescope. And well, in essence, it shows us a dramatic change in color. When this comet was first detected in July, it appeared to be a slightly reddish tint. And this is believed to be the result of something referred to as tholins, a variety of organic compounds that a lot of other objects contain as well, and basically the same compounds that make Pluto a little bit reddish as well. And so when a lot of these organic compounds get illuminated by cosmic rays or even ultraviolet light, they eventually form this reddish material. However, as the comet emerged from behind the sun, which happened in late November, new images from the same telescope reveal that it's now just a little bit more green. Or essentially now it contains a definitive greenish glow, which implies a slightly different composition. And normally this is caused by diatomic carbon, so basically C2, carbon that binds to itself. And so as the sun's heat penetrates the comet, these molecules are released and then excited by solar radiation, emitting light at green wavelengths. But here it's important to understand that this is obviously not unusual at all. Pretty much most comets display the same light, except that here, compared to local comets, this behavior was dramatically delayed. Normally, most of the solar system comets form this green halo way sooner. And well, that of course suggests that the surface of this comet was probably just a little bit different. We've actually discussed the actual reasons for this in one of the previous videos, but in essence, on the surface, it seems to have this very thick crust that formed as a result of billions of years of exposure to outer space, and specifically to very powerful cosmic radiation that this comet was exposed to as it traveled across the Milky Way. And that implies that this particular interstellar comet reacted differently to heat compared to comets we're used to observing. So not super unusual, but a little bit unusual. Here's actually another really cool time-lapse that shows us 2 separate comets in the same image. Although in this case 3i Atlas is barely visible. This was taken by the researchers from the Southwest Research Institute. And then we have additional images from the X-ray telescope referred to as XMM Newton, the telescope you see right here. And this was actually one of the most scientifically significant observations this month, originally conducted on December 3rd, where the telescope watched this comet for 20 hours. And well, it detected this, an X-ray glow. And well, here this is actually the result of a lot of stuff coming from the comet interacting with the solar wind. Specifically, when the gas molecules stream away from the comet, they then collide with the solar wind, which are of course charged particles coming from the sun, which creates X-ray fluorescence. But what makes this X-ray observation just a little bit unusual is that in this case, these X-ray observations are uniquely sensitive to gases like molecular hydrogen and nitrogen, which are almost completely invisible to optical telescopes, like for example Hubble telescope. And so in essence what we're seeing is hydrogen and nitrogen. we're seeing hidden ingredients that would be otherwise completely invisible. And that, of course, is going to help scientists in the next few months to piece together what this comet essentially contains inside and what kind of elements and in what amounts it seems to contain. So if it wasn't for this X-ray telescope, we would probably never be able to see either hydrogen or nitrogen. Although here we do have additional pictures from Hubble as well, with this comet appearing just a little bit brighter and a little bit bigger compared to previous observations. This was from December 5th of 2025. Then we have something really exciting coming from this study by these 3 European researchers. And here the analysis suggests that this comet seems to behave like a typical trans-Neptunian object and is basically experiencing what we refer to as cryovolcanism. And so here, by observing this comet, scientists believe that as it heated up, a lot of solid carbon dioxide, or dry ice, turned from ice to gas directly, and very likely inside the nucleus, which in essence made this comet do something like this. And this process may actually trigger the flow of a lot of oxidizing liquids inside the comet, that then react with a lot of iron and nickel grains locked inside the comet. So essentially it kind of initiates a bunch of chemical reactions, which might explain additional observations from the last few months. And so here this internal corrosion creates a lot of energetic chemical reactions that eventually blast jets of gas and dust into outer space. And this may actually also produce what's known as the non-gravitational acceleration, essentially shifting the comet's orbit by just a little bit. But this is of course something we've seen many times in the solar system. As a matter of fact, we've even discussed one of the most recent discoveries from an extremely famous cryovolcano right here in the solar system. You can learn about this in one of the videos in the description. But so far this indicates that the chemistry of 3I Atlas is remarkably carbon-rich. It essentially seems to be spewing out a lot of methanol and hydrogen cyanide at much higher rates than any other comet in the solar system. And methanol is actually particularly important because it's technically a building block for a lot of prebiotic chemistry that we believe existed on early Earth. And so at least when it comes to our own planet, this kind of stuff was crucial for starting life. And so seeing these ingredients in a visitor from a different star system definitively tells us that fundamental ingredients for life seem to be quite widespread in the entire galaxy. And then, as I mentioned in one of the previous videos, we have some additional pictures from missions in space that were actually on the way to a completely different planet when scientists decided to use their cameras to take a look at the comet from a different perspective. And so here we have our first picture from the mission known as JUICE, Jupiter Icy Moons Explorer. And so because it was so close to the comet, it was able to capture the view showing us an active coma, plus hints of both the plasma tail and a much fainter dust tail. Something that's typical for comets, but something that was difficult to see before. In this case, the plasma tail is just a bunch of ionized gas, and usually points away from the sun, and the dust tail is formed by ice particles, and usually moves in a different direction. This is basically material released by the sun as the comet heats up. Both of these tails are actually very different, because the plasma tail is made out of ionized gas, and the dust tail is made out of solid particles. But the separate mission known as the Europa Clipper that you see right here observed the comet from the opposite direction, and it produced this image. And so here, by using ultraviolet observations, scientists observed the comet's nucleus, its coma, and dust tail from a unique sunward perspective, in the process detecting oxygen and hydrogen, despite the comet being covered in a lot of gas. So this is essentially what you're seeing in this image. Now the details about this are going to come out sometimes in February or March, but for now at least we get one image. And then this particular study that was just released a few weeks ago was even able to determine the approximate mass of the comet by essentially observing by how much it seems to accelerate due to the emissions of all of this gas. And so here the rough mass estimate suggests that it's approximately 44 million tons, or at least it used to be this heavy back in August of 2025, suggesting that this comet is predominantly made out of CO2, and the total size of the nucleus is actually relatively small, just over 700 meters in diameter, or approximately 2,300 feet. And this is definitely much smaller than scientists previously assumed, because it was believed to be much larger, up to about 5 kilometers, with the scientists behind this study discovering something else. In essence here, by observing the tail of the comet, Sarah Rickard and colleagues from the study detected a faint high-latitude jet where they were able to track its wobbling motion, and this allowed them to then derive how fast this object seems to be spinning. Or basically they were able to see the rotation period of the nucleus itself, and it seems to be approximately 15.5 hours, which was the first time this periodic jet angle modulation was done in an interstellar comet, and allowed scientists to determine spin axes without direct nucleus observation. But this also suggests that a lot of this outgassing early on potentially changed the rotation of the comet, because it might have been a little bit longer before at over 16 hours. So essentially in this case, the comet seems to have spun up. And last but not least, there's one thing I never really got to mention in any of the previous videos. The person who found this, obviously completely by accident. He was actually this wonderful person, Dr. Larry Denneau, one of the members of the Atlas project, who captured the comet using Gemini North Telescope in Hawaii in July of 2025. And here's actually the first picture of the comet from July 1st. And so he discovered this by reviewing routine telescope data from Hawaii's Institute for Astronomy, and initially was thought to be an ordinary near-Earth object, something that scientists detect pretty much daily. But eventually, because of its hyperbolic orbit, that's when things got really exciting. And so within just 24 hours, this was confirmed to be the third interstellar object. And this highlights how incredibly powerful this Atlas telescope is, because it's able to scan vast areas of night skies, capturing images of pretty much any moving object. And the reason this is important is, of course, in the name of the telescope. ATLAS stands for Asteroid Terrestrial Impact Last Alert System. Its main purpose is to detect any potentially dangerous asteroid before it collides with our planet. So this is a very important planetary defense telescope. But the reason Larry Denneau in this case was important is because of his non-traditional background. With a degree in electrical engineering and computer science, he developed ATLAS software that can handle terabytes of data pretty much every single night and extremely accurately and reliably alert us of any potential danger. So technically this is one of those superheroes without a cape. I mean, most of us are not even aware this is happening, but here scientists are constantly observing the night skies to make sure that nothing is on a collision course, and to make sure that if something is on a collision course, we're prepared way in advance. As a matter of fact, his software was also responsible for the other exciting discovery from 2025, the asteroid YR4 that we discussed previously, that at first scientists thought may collide with the planet in 2032, but is now technically on a collision course with our partner, the Moon. You can learn about this in one of the videos in the description. And so that was, of course, the discovery of the comet and the person who confirmed its existence. And so I hope someone in Hawaii buys him a beer or something. I mean, this was a pretty remarkable discovery. But anyway, we'll definitely come back and discuss the subject in some of the future videos, probably in the next few weeks, because after these December observations, we're going to have even more data and more analysis from several different teams. Until then, check out some of the previous videos in the description. Thank you for watching, subscribe, come back tomorrow to learn something else, support the channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also buy the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.